Hi, I'm Tommy.
Hi, I'm Nemanja. Welcome to Cloud Couch.
It's where we discuss cloud topics from a couch perspective.
Not so comfortable couch.
Welcome back to another episode here in Cloud Couch. And we are continuing our series on Cloud Journey.
Yeah.
And today we're going to talk about the migration part.
Yes, migration.
So in the previous episode, unless you already watched it, you can check out the foundation. So we were preparing everything from identity to landing zone to organization, accounts, and all the way up to kind of prepare and set the basic foundation for now starting to move over applications in one by one or in batches.
Yeah.
So today we're gonna just quickly to summarize a bit what we're gonna look at before we dive in. So we're gonna look at setting up an environment for the applications.
Yes, each application has its own environment.
Yeah. So runtime basically, and then we're gonna look at the data attached. Then we're gonna look at the applications themselves, and then as a last piece, we're going to look at development just as let's say, on the surface, basically, before I would say another or 1-2 other episodes, we're going to look into the details much more around development and engineering in the cloud.
Yes, exactly.
So with that, let's maybe start with environment.
Yeah, so each application has its own environment, right? And you need to bootstrap this environment to prepare it for your application and data once they land there. We're not talking about accounts now that we have done in the previous section. So how do you create environment? How would you create the environment in the cloud?
It's different options. I guess you can manually click, but
you can manually go. I hope people don't do that a lot.
Yeah, absolutely. Yeah.
But it is a way, yes. And I would say when customers and people are starting with the cloud, that's actually how you learn. That's how you try. You open a console of your preferred cloud vendor, whoever that is, and you click around and you say, I need a database, I need a virtual machine, I need this service, that service, and you see how that fits together. But if we are talking about structured migration approach, then there is something else you need to do, right? And that is scripting your environment with tools like infrastructure, known as infrastructure as code. Yeah. So what are the tools out there for infrastructure as code? What do you use? What have you used of this?
I've used many different ones, especially, let's say, if we would even talk on-prem and things that are a little bit, let's say, closely related. But for cloud, we both are much more fluent in AWS. So there, I've tried out CDK at an early stage, but didn't, have the maturity, so it really works. But it's really, for me, I like CloudFormation a lot. It's pretty mature, works really well. So for me, that's an obvious thing where I would start. And for me, it's a absolute no-go to do things manually, and it's like interest on interest. If you start out with infrastructure as code and you have automation with pipelines, that's just the way to go. But there's many other tools.
Infrastructure as code is a script, and it's basically a piece of source code like any other. Should be in a source code repository, should have a pipeline associated to it. CloudFormation, when we talk about AWS, is a main infrastructure as code tool, and lots of other tools are built upon that. So CDK, Cloud Development Kit, I prefer more than CloudFormation because CloudFormation is JSON and YAML large script, whereas CDK is higher level construct where you use programming languages like Java, Python, TypeScript, C# to script your code in.
Yeah, and today it's much more mature. I think
yes.
We'll dig into that when we discuss more the specific projects, especially in the startup. But today I would agree it's the way to go.
But those are not the only tools. These tools, two tools are from the AWS shop coming, but there are other tools that known as like Terraform, for example, from HashiCorp. There is Pulumi. There are some other like Chalice, Zappa, and so on. More open source tools. CDK is open source as well, by the way, with lots of contributors. But these other are also multi-cloud environments. So if enterprises, if companies are thinking about deploying to multiple clouds, then they should take one of these cloud agnostic tools like Pulumi or Terraform. But if you're putting everything into one cloud, let's say AWS, then use the toolkit from that cloud that brings the most of the benefits, and stick to the options that cloud provides you, and what has been proven to work best.
Yeah, and I think a really important, basically an analogy that I'm using many times is looking at mobile development, and you have Android, iOS, and then you have all these cross-platform types of technologies you can use. So I see the same, like if you do cross-platform, you can basically code once and then deploy multiple, but it also means you have limitations on native platform-specific features.
Yes, exactly.
And you might not have the latest and greatest, or actually you don't. So there's a lag, but if you don't need all these things, it can make sense. And it's the same thing here with Terraform. It's for sure not going to have all the latest features that AWS is pushing out, or Google or Microsoft. So you're just on a common denominator across these platforms, and on some kind of generic level. So maybe it doesn't even support certain cool things.
So yeah, they are trying to keep up, but I mean they have their own sort of scripting language that describes the higher level constructs and concepts. But I mean, clouds in general are not compatible. I mean, as soon as you move above the virtual machines, the APIs are not compatible. So these cloud agnostic vendors, they are trying to implement all different APIs from different cloud vendors, but it's becoming a bigger and bigger effort. I personally don't know how far and how long
you can push it.
You can push it, and you can keep up. Every cloud is really running sprints, and these sort of cloud agnostic infrastructure as code providers, they need to keep up. And that is difficult. That's
absolutely agree. And I think even you can see all the things AWS is pushing out, and then oftentimes people are complaining or just pointing out that CloudFormation doesn't have support for this yet. So even inside you have this problem. So obviously you could imagine, will CloudFormation get the support first, or will Terraform get it? Well, it's pretty obvious who has the bigger incentive. It's CloudFormation.
It goes back to our discussion in the previous episode about service baselining. So if you want to script your environment with infrastructure as code, then you make sure that whatever tool you have selected for infrastructure as code has a support for your services. So CloudFormation, CDK, they don't have the support for everything. They're trying to keep up, but it's not there. The same is for other tools like Terraform and so on. So yeah, that's, I would say, in general about the creating environment, bootstrapping the environment for the applications that you want to migrate to cloud.
Yeah, absolutely. And like we said, we definitely see that that's done with in code, and you have pipelines, say with automation, so you have something that's
manually,
no manually, because this is something you're going to build on top of going forward. Every change you do, this is part of that agile team and that agile organization that you're also building moving into the cloud.
Yeah, and usually these things like environment bootstrapping scripts are done by DevOps teams in companies that they are the one that understand what application dependencies are, what they need, what are the services that they will use. They understand how to create that in the cloud, and they are the one responsible for writing and maintaining the scripts.
Yeah, maybe just a question here to kind of make it really clear. What's the benefit of doing manually?
Benefit of doing manually? It's quick and dirty.
Yeah, but is that a benefit?
Yeah, that's there is no benefit of doing it manually.
I think that's the point. I don't see that there is none. There are only disadvantages.
Yes, during the experimentation and learning and testing phase in your dev account, yes, and there is a benefit of doing it there. There is absolutely no benefit doing it in any later stage environments, testing, pre-production, production environments, absolutely. Nothing should be done manual over there.
Yeah, absolutely. And just an anecdote from when we were talking early on when we met and then started talking projects. So I just remember you were commenting on also like keeping the people out, like nobody should have direct access as a human to change production.
Yes.
And I think this is a very...
Humans are bad.
Yeah, absolutely. We know it from everything from trading, you have a fat thumb and you all of a sudden you tank the market because you did something wrong. And it happens all the time. And I think that's really such an important guiding principle, and also comes back to this now. It's to realize there is no benefit with manual. You only have risks, and you should rather think, okay, let's keep humans out and let's work with automation that is deterministic, fast, and also very low risk to make changes.
Yes. Because, and how often do you think people are doing that?
Maybe you tell. How often does that happen in a migration situation?
The thing is, I would say most of the customers that I've seen, and they do have intention to do everything by the book and writing infrastructure as code, but then the pressure kicks in, the deadlines kick in, the funding starts disappearing, and you have to show something in the production, and this is the time when you start taking shortcuts. And the same like documentation,
or testing.
Or testing, yes. That there is no developer in the world who likes to write tests or documents, right? And at least I don't like to write documentation and tests, but it is necessary to have, of course. If you're under a huge pressure, if you need to deliver, and you will say, I can script it in infrastructure as code tools, which will take me 3 days, but I can quickly just click there and I'll have it immediately, and my job done. So these are the things that should be prevented, and if you think about these things from the beginning, from day one, and it's like with tests, if you make a test-driven development and you do it from day one, then everybody will be doing it. It will be part of the process. If you leave it for the later stage, you're probably never going to do it.
Optional homework. Absolutely agree. And I think that the illusion here is that it's cheaper, better, and as good, because you didn't get yet the negative feedback down the road. Instead, you need to compare it to interest on interest. Like back then when we had interest rates in the savings accounts, we could accumulate a lot of money over a long time. And it's the same thing if you're working with infrastructure as code and automation. And this is obvious for people who have experience like us, that we have done it for many years, not just for infrastructure but also in software. I mean, it's the obvious way to go, and it's just sad that you need to start cutting corners that you should not cut. These are not optional corners to cut, but it's unfortunately
it will hurt you down
happening.
The line.
Absolutely.
Eventually the pain is inevitable.
Yes. Okay, so now we know environment, so that's now infrastructure as code, pipelines.
Yes.
What's then after? Data,
yes. So in the migration process, we need to separate data from the application code and to move data, and then there are different types of data, right? That there is like a static data and transactional data. Static data would be any kind of, you can even think of archives and backups that need to be there, static files that your applications are using, images, videos, any kind of documents, whatever it is. So these data are relatively easy to migrate. It's just the size of it that is quite often a problem. But you can detach it easily from the applications and move it independently from applications. Speaking of size, so this is where there are several options how to move data. But it depends if.
Let's start with not so big size.
Yeah, just upload it. Right.
Upload.
There are different ways to
over internet.
Yeah, there are different ways to upload to. In AWS, you use even some kind of transfer acceleration mechanisms to upload, but it's basically just copy paste and upload it, and you can start right now. If it takes 3 days, okay, it takes 3 days, but that's it. You have uploaded data.
Yeah. So it gets into really the same thing we have been discussing over many years in IT, basically, that at what point is it cheaper to send an employee, let's say, with a hard drive across the Atlantic with the data versus uploading it over your internet link.
Yes.
So obviously at some point you cross the line and you realize, okay, we have a lot of data. What do? Do we send employees over, or how does it work usually in the cloud?
Not anymore.
Yeah.
Yeah, I mean, cloud providers, cloud vendors have different, I would say, services that help you with mass migration of data. If we talk about AWS and
it happens.
Yes, it happens. The part of the infrastructure.
Must be something manually set up.
Yes. It's your fault. You didn't script it. They have services to do the mass migration of data. I mean, in AWS, for example, that's quite often referred to as a Snow family of products. It's like from a snow cone, a little
that's a new
one that move a couple of terabytes to snowball that is like a suitcase. Up to 100 terabytes that can move, or even if you have more data, it's like a truck that comes to your snowmobile, right?
Cool.
So these are ways to speed up the data transfer. You don't want to move your applications and everything there and then wait for another 2 months to get the data up there. I mean, you can all finish it with these kind of services in 7 to 10 days, right? So this is the part of the static data migration. Right? Then there is a second one, right? It's not all about static. It's there is most of it's transactional, so it's in the databases.
And maybe on that, maybe you want to speak to splitting it into whatever's in the databases, but also whatever is produced live, and also having a conversation of, are you stopping the applications, or are you hybrid thing, or what's the conversation usually here?
Yeah, so that's a good discussion to have always. Like, are there databases that you can just take it, make a cutover, create like a migration window where applications stop writing to a database, and then you just copy and paste it, right? And how do you do that? You can do traditional way of take a backup and then restore it in the cloud on whatever database engine you're running there. If you're in the area where you can't stop your application and can't stop your database for even a moment, but you still want to migrate it, you need to use some of the these real-time data migration services. All right, and in AWS, for example, there is a service called DMS, Database Migration Service, that works on the live source database and the destination database. So you can connect it. It is one-off. It should be used for one-off transfer, but once you have moved the application stack there, and then you have your application running in active mode, both on premise and in the cloud, with the two databases that are synchronized with DMS service, then at some stage you can just redirect users from your on-premise to cloud. They don't notice any interruption, they continue working, and then you can switch off the source database, you can switch off the DMS service, and this is how you have done the live migration of databases as well. So this transactional part.
Yeah. I mean, for me, this is where I would start, at least to look at how to migrate, because ideally you don't have any interruptions. And you can just replicate the database, as you said, on the go, basically, and you can have a much more how do you say, without interruptions, switching over, and you're just benefiting from getting a replica basically, or a mirror. And it's much more than the discussion, how important is that? How, maybe, it's just over-engineering it because our application can easily have a long window. Maybe the data size is so small, whatever it is. But at least I would start there and at least look at, okay, let's just replicate over and have this, maybe even a hybrid going forward, that you have both on-prem and in the cloud, and you're just, maybe even keeping both.
I would say most of the businesses, like 99% of the businesses, can have a controlled downtime and maintenance window, be it Saturday evening or mid of Sunday. There are businesses that are, I don't know, in the streaming or shopping, e-commerce space that probably cannot afford that. But most of the businesses out there can have a cutoff and move it. I mean, even in the trading, you were in trading, like when were the migrations happening in the trading business? It's over the weekend, I guess, right? When the exchanges are not working.
I mean, it's very interesting, and let's dig a bit deeper here, because of course in trading it depends what are you trading, when is the market open. Well, if you're trading, let's take Forex for instance, so any type of currencies, it's open all the time.
Even the weekends as well.
Yeah, I mean some are. And then if you're looking at now crypto markets, I mean they're open all the time also. So it's more like, you have some windows that are natural in some cases. Also business that, depending on what kind of business you are in. But in some cases you don't have. And I think basically the point I'm coming from is just to see, there's another aspect to the whole thing, and that is making sure it works in the cloud, where you can, get both benefits of having no downtime and immediately testing that it actually works. So it's like, let's not imagine there's a line in the sand where, we have to jump over. Instead, it's much more, we know it works because we are testing it all the time. I mean, that's what I think personally is very interesting, because you minimize the risk and you are just actually using the services, in my view, in a way which is not more complex, or there is no additional risk or anything. It's more the conversation about how much data do you have, is it practical, is it economic, things like that. But okay, so data, we moved over.
Now we have data there, we have a environment there, we have data, applications are missing.
Applications are missing. So, and also just to quickly summarize, the environment basically also meant we also commissioned the data storage services, obviously, and for the applications.
Exactly. So we created those services there. Then we fill them up with the data, and now we need to do something with the applications to make sense out of those data, right? So how do we move the applications?
Yeah, absolutely. And maybe just also quickly remember back what you spoke about, or what we discussed in the previous episode, where we have these different 6 different ways of moving over applications. So lift and shift, and these
drop
different
and chop.
Drop and chop. Yeah, absolutely. So what are the common ones, especially now in this context of enterprise, corporate, moving over there most of the time, legacy applications? But what are the options really here? Not going
for the applications.
Yeah, for the applications.
I would say there are 2 main ones, and that is the lift and shift. So, or we call it back there like rehosting, right? And the other one would be replatforming, right? So these would be the easiest ways to move the applications without much intervention inside those applications, or changing of those applications. Lift and shift, let's say if we just think about moving on the level of virtual machines, right? So if your environment on premise is virtualized, running VMware, for example, or Hyper-V or something, you can make snapshots out of those and then move it to, let's say, AWS as Amazon Machine Image and restart it there. And there are lots of services and tools that can help you in that. There is in AWS SMS service called Service Migration server migration service that is actually doing that, like kind of snapshot and creates AMI. There is also a company called Cloud Endure. So AWS has acquired Cloud Endure. So Cloud Endure is now like a service in AWS that is specialized for migrating virtual machines from on-premise to AWS environment. And these are the easiest one to rehost, right? So get rid of host on premise, get some other host in AWS, and just run it there.
Yeah.
Your data is there already, so you can just link it. Right?
Yeah, absolutely. And the whole point is to minimize the risk, obviously, in this first step. We are just taking what we know is running on premise as is, and we just, like you say, copy paste the server over to cloud. And then when we know that works, obviously there's another discussion then what to do next.
Optimization starts.
Okay, so that's like copying a whole machine. So obviously there are other options we could be looking at.
Yeah, I would say the other that goes into this easier direction would be like containers.
Yeah.
So if you already have containerized environment on premise and you're running whole bunch of Docker containers, you can easily move those containers into AWS environment, for example, or any other cloud vendor environment. But in AWS, for example, there is a wide variety of choices where you run your containers. You can run them on EC2 instances, the same like you have been doing on virtual machines on premise, or you can use more managed orchestration services like Kubernetes, EKS, ECS. There is also like Lightsail, there's Elastic Beanstalk. Even recently just like announced, you can run containers in Lambda as well. So those are the options. But if your application is already in a container, it's easy to run that container somewhere else. If it's not, then maybe there is an effort needed to put it in a container prior to migrating to AWS.
And absolutely. And I think this is a very important thing here to realize. Why would you do that? Put it in a container. So of course you might be, on one side you might introduce some risk because you didn't do that. You didn't run it yet on premise. But the whole point is that it becomes much easier to migrate or to even know that it's going to work because you have that much more deterministic environment. So of course you could be saying, let's containerize it and test it on premise before.
Exactly, yes.
And then we just have something where we're moving it over.
Then the confidence level is really high that it's going to work there as well.
And it's interesting, and also what you mentioned in terms of let's say the hosting of containers, running the containers. I also know, like you mentioned, ECS, which is something I've been using also for a few years. And there you have also the option of doing EC2, so dedicated
worker
nodes versus more like the serverless, because you're piggybacking on Fargate. So basically it's like automatically or in a much more automated way dealing with the nodes and the hosts, the servers basically that run and should scale obviously and all this stuff.
Yes.
Any thoughts on that in I don't know, any best practices or what to do first? Does it, how is, serverless or Fargate used in this context for usual, migrations from enterprise? Is it at all, or they do EC2?
I think serverless is a different topic that we will address in a later stage. When it comes to enterprise level migration to cloud, I don't think serverless is there as a first choice, and that's good. It shouldn't be, because it involves a little bit of changing of practices. Also, how do you develop and test? If you have a, let's say, containerized environment on premise where you can test it, when you can develop it, you can start it on every laptop and every developer can see it. Once you move to the serverless world, there are some things you cannot do anymore locally, right? It needs to have a good deployment pipelines into your cloud where you can actually test it only there, because there is a dependency to other services that cannot be run locally. So I would say moving containers to AWS, quite often companies go for worker nodes as EC2 instances, or even self-manage Docker running on EC2 instances without these orchestration engines like ECS or Kubernetes and so on. So, but whatever method is chosen, whatever works the best for the quickest migration, that's the one that should be taken, and then we'll think about optimization.
So now it's in ECR, and you have ECR being the registry for containers for Docker images, and the same you would have if you have AMIs. You have them already in AWS, so you can just spin up new virtual servers.
Yeah.
So in both cases now you have applications in different deployable artifacts or whatever you want to call it. And now in the last part, which is development, we want to look at connecting that into automation pipelines and also, of course, the source code, so that we can start moving over developers and producing new versions of the applications, basically.
Exactly.
And I just want to make a clear statement that these pipelines and automations are so important in order to be able to move fast, minimize risks, also a lot of costs that are hidden obviously with troubleshooting and things not working or on all levels. So it's so fundamental to have this very clear approach how you are using automation and pipelines all the way from infrastructure now to the applications.
Yes,
so
moving the applications and data is just a first step, but that's not the end. So once it is there in the cloud, how do you continue evolving those applications? And that is the development piece. So when talking about development, what do you do with source code repository? If it was on-premise, do you move it to cloud, which you can? Do you move it to some third-party solution, GitLab, GitHub, whatever, if it's not already there? And then creating the pipelines to, if you haven't done it already, I mean, if your code is in GitLab and GitHub and you're already using their CI/CD pipelines, then fine, that can just stay as it is, and the end artifact can be deployed in the cloud instead of your on-premise. But if you don't have that, if you have to build it, right, it's important, I think, to understand that it needs to be there, automation. Otherwise, any kind of automation you have achieved by moving to the cloud, you have stopped if you don't fully automate your development activities as well.
Yeah, absolutely. This is a non-negotiable. It needs to be there. And my question would be, where are companies usually having source code, and how many of these companies that you've been working with through AWS over the last years actually have even some kind of pipeline in their on-prem setup? Because I know this since 16 years now. I've been working with software engineering and doing pipelines, so continuous integration, and now we're talking about continuous delivery and even deployment when we're talking cloud. So where do they start from, basically?
It depends.
Yes.
Different companies are on different levels of maturity. Even the large enterprises have different departments internally that are more mature than the others. Some have really everything automated. Usually company policies require that the code is stored internally. So there are internally hosted Git source code repositories that are being used, and internal, it can be, let's say, some CI/CD like Bitbucket from Atlassian that is used internally. And so it really depends. Smaller companies, startups, for example, they are almost all exclusively on GitHub or GitLab, using private repositories and using CI tools that come with these environments, and from there then deploy somewhere else. So it really depends. But I have seen also companies that are doing things manually. Like that,
I've seen also that.
Source code is on the laptops of developers, and there is a huge risk there. There is a huge audit and compliance risk.
There are no benefits.
There are no benefits, and but sometimes there is a key dependency to those people, to those developers, and even if the company would like to have it differently, there is a key person dependency, and that person holds all the strings, and everything is on his laptop, and things are great as long as they are running and as long as that guy is alive. But the moment something changes there, you're jeopardizing a lot. And this is another driver that to go to the environments like cloud environments where you can share things and where you can automate and reduce these key person dependencies.
Yeah, absolutely. I mean, this is such a fundamental both insight, but also piece of infrastructure, not only technical, but also in the teams, in the organization. So we will definitely come back many times, and we're for sure going to do dedicated chats around pipelines and agile and how to do this, because it's not optional. So you have to do this, otherwise you're just going to have disadvantages. Now there are some, let's say, how do you start from where you are and where do you go? But the goal is clear, where you need to be, where you have everything is transparent and integrated and automated, so you have a platform to actually operate on top of.
Yes.
And this is such an important thing, because if you don't have that, you are actually blocked from so many benefits, and you have only disadvantages. And in addition to that, there are all these more advanced topics that for sure we're going to talk about later, which comes into data security. You mentioned that they want to keep things on-prem. It's okay, but it also comes into how do you want to work as an organization? What's the tooling in the development team? What kind of systems do you use? What kind of reviewing process do you have in order to finally merge something into your source code main branch, basically. There's so many connected topics.
And also you mentioned operating. So this is, I mean, even if you have automation in the development and application, everything is in the cloud, there is a huge outstanding piece, and that is operating those applications. So monitoring and operations, and that is the part that we're going to discuss in the next episode, a little bit more into details. And I think we have, in this episode, we have covered lots of things that in our view are non-optional. We're being very bossy in this episode, but it is for the best for the benefit of enterprises, right, and companies. Like you can do quick and dirty things, but it will definitely hurt you down the line. And
absolutely. And it's not just having an opinion. It's like many different companies, businesses, and also projects that we've been doing, and seeing how these tools have been evolving over many years in terms of using automation. And in the end, it's not because we are now talking from or putting on the technologist hat and talking about this is so fun to do and it's this technology. It's not that. It's really from the business point of view. You want this because it allows you to be lower risk, less costs, faster, and you are agile, and you can operate on a platform where everybody's collaborating, and it's much more transparent, and you can even then start discussing topics like innovation and continuous improvement.
Yeah, future proof.
Yeah, absolutely. Yeah, cool. So next episode, operations. Operations,
yes, a lot of fun.
Yeah, a lot of fun. Yeah.
Yeah. See you then in the next episode.
See you. Thank you.
Bye.
So if this is a relevant topic for your business, just contact us so that we can help you.
If you like what we are doing, please subscribe to our channel and like our videos.
And also you can give us feedback and also suggestions for topics that you would like us to discuss and go into more detail.
In any case, stay tuned and see you soon.